study with Tanzania Institute of Education.
Welcome students, how are you? Okay, my name is Haji and the topic today is Pythagoras Theorem, Mathematics from 2. Again, Pythagoras Theorem. Pythagoras Theorem is a mathematics theorem that used to solve problems involving right-angled triangle. It's a theorem that used to solve problems involving right-angled triangles. If you work through trigonometric ratios, sometimes you can have a challenge, and the challenge may be to find the size or unknown size in a right-angled triangle. So the only solution is to use or to apply Pythagoras theorem. Previously, we discussed about trigonometry, and I think you still remember the tree, and it was a challenge to find the height of the trees. But now we can find the length or the height of the trees, as well as the length from the base of the tree to the point where the angle was measured. But another challenge is to find the length from the point of the angle to the top of the tree. So the only way is to find, we call it hypotenuse. So the only way to find this length is to apply Pythagoras theorem. It was a challenge during that times, but in 60 years ago, a Greek scientist called Pythagoras came up with a solution to solve this, to find the length of the hypotenuse of a right-angled triangle. The theorem states that if for a given right-angled triangle, let us say A, B, and C. This is a right-angled triangle. The square on the hypotenuse, the longest side, is equal to the sum of the squares of the other two sides. Again, the squares on the hypotenuse, AB, is equal to the sum of the squares of the other two sides. So Pythagoras theorem states that Pythagoras theorem states that in a given right-angled triangle like this, in a given right-angled triangle, the square of hypotenuse is equal to the sum of squares of the other two sides. The square on the hypotenuse, the longest side, is equal to the sum of the squares AB, AC, and BC. It means, according to Pythagoras, AB square, which is the hypotenuse, the longest one, is equal to AC square plus BC square. And if we call this side a small c, and the side is opposite to A is small a, and finally is small b, so the same theorem can be written as c square is equal to what? AC, where AC is b square plus BC. BC is what? A square. So c square is equal to b square plus l square, or c square is equal to a square plus c b square. It means, according to Pythagoras theorem, if we have a triangles of three sides, right-angled triangle like this, and the two of the sides are given, it is possible and simple to find the length of the third side by using what? Using Pythagoras theorem. What Pythagoras says, the square on the hypotenuse is equal to the sum of the squares of the other two sides. And the theorem should be proved. There are alternatives to prove Pythagoras theorem. One of the way you can use the concept of similarity. But for today, let us use other method, which is usually the square method. So now let us prove Pythagoras theorem using square method. Here we have two squares. The first square is the square PQRS, and another square is which lies inside the first square, which is KLMN. So we have the squares PQRS, the first one, and another square which lies inside this square, which is KLMN. So using this way, it is possible to prove the theorem which says that the square on the hypotenuse is equal to the sum of the squares on the other two sides. Okay, so if you look this, whatever you have a geometrical idea and you are interested to prove, there are some procedures to follow. One of the procedures is to join, to construct. And our construction here is to join the line MN. And the line MN will bisect the two squares into two equal parts. So if we bisect this using the line LN, and now we have two parts of the squares. This side, it means we can call it PQLN. And another one, NLRS. So you have two squares which are equals. But we are interested to take only one and forget about the second squares. So now let us use P, Q, and L. So P, Q, and L. P, Q, and L is a rectangle for one side. But we can call it also is a trapezium. It is also a trapezium. It's a rectangle because a rectangle is any four-sided figure like this, but also it is a trapezium. Why trapezium? Why that this is a trapezium? Because when the bases of trapeziums are equals, that trapezium is said to be a rectangle. Let me show you to be comfortable. Assume we have a rectangle like this with length L and the width W. And also we have a trapezium like this with length, our base L, and let us say base 2 is W. And always there is a height, whatever you say. Or you can change, this can be a W, and this is length 1, and call it length 2. The area of a rectangle is what? The area of a rectangle is length times width, L multiplied by W, which simples L or LW. And what about the area of a trapezium? The area of a trapezium is half into L1 plus L2 multiplied by the height of the width. This is the formula to find the area of a trapezium. But if L1 is equal to L2, so the area becomes half, then L1 plus, here is L2, but L1 is equal to L2. So it depends on your choice. You can accept L1 or L2. Let us use L1. and multiply by W. So the formula becomes 1 over 2 into L1 plus L1 is twice of L1 times W. So it is possible to cancel 2 and 2. If you cancel 2 and half becomes L1 multiplied by W is the same as LW. And this is the same as a rectangle. So it means there's a situation that trapezium can be a rectangle if the bases are equal. So it means our proof, we can consider that this is a trapezium and not a rectangle. Okay. So now let us find the formula for the area of a trapezium. If we consider this, it means the area of a trapezium, or the area of PQLN, PQLN is equal to what? Is equal to, we have half into A plus B, base 1 plus base 2, multiplied by the length or the height. So from here to here is B, and this is A. So it's the same as A plus B. A plus B. So we have A plus B and A plus B. And the area of a trapezium is the same as adding the area of 3 triangles. We have triangle number 1, triangle number 2, and the triangle number 3. So it means the area of a trapezium is the same as adding the area of 3 triangles. So we can say area of triangle NPK plus area of triangle number 2 KQL plus area of triangle number 3 with side CH NKL, triangle NKL is equal to area of trapezium. Area of trapezium. But the area of the general formula for the area of a triangle is half base times height. So for here it means the area is half base times height, and here half base times height, and also half base times height. For the first triangle, half will be half times base is A and height is B. And another one, second triangle, the shaded one, still half B or A times B. Half A times B. And another one, the last one, the triangle has sides, the base is C and the height is C. So we have half C times C is the same as C squared. And the area of a trapezium still half into A plus B into A plus B. So here, half is common for those parts here, here, and here. So we can put half as common, and then we have AB, this one, and also plus AB, the second part, but here we have C squared. And this we have still half, so we can expand the two brackets. If we expand A times A squared, and A times B, AB, B times A, AB, and B squared. But it is possible to cancel half through sides. So you can cancel half and this half, and the remaining part is AB plus AB is 2AB plus C squared is the same as having A squared for this side. And we have AB plus AB is 2AB plus B squared. And also subtract 2ab throughout. If you subtract 2ab throughout, now the left-hand side becomes c squared, and the right-hand side is a squared plus b squared. So this is proved that Pythagoras theorem for any right angle triangle, the square on the hypotenuse, which is c squared, is equal to what? Is equal to a squared plus b squared. So therefore, c squared is equal to a squared plus b squared. So it means it is proved, and the theorem can be used to solve any right angle triangles. But take note that Pythagoras theorem applies only for triangle which is a right angle triangles. And the secret behind the Pythagoras theorem is that suppose we have this right angle triangle ABC. The square on the hypotenuse is equal to the sum of the square of this. But the sum of the lengths of the two sides must be greater than the length of hypotenuse. I repeat, the squares on the hypotenuse, this, is equal to the sum of the squares of the other two sides. That is the one. But the sum of the lengths of the other two sides must be greater than the length of hypotenuse. And that is a right angle triangle. Otherwise, will be a triangle, but not a right angle triangle. And after this, now we are in the right position to apply Pythagoras theorem to solve any right angle triangle if one of the sides is not given. For example, suppose we have questions that needs to apply Pythagoras theorem. The question says, example, let us say example number 1. This is example number 1. Example says, the size of a triangle the size of a triangle, the side of a triangle containing the right angle, containing a right angle. The side of a triangle containing a right angle have length of 5 centimeters. Have length of 5 centimeters. So one of the lengths is 5 centimeters and another length is 12 centimeters. And 12 centimeters. Question. Find. We have the triangle at 3 sides. The 2 sides are given. So we need to find the length of the other side, which is hypotenuse. So find the length of hypotenuse. So this is a question is reflect the concept of Pythagoras theorem, and to answer this question you have to apply Pythagoras theorem. And it is very, very important, or it is advisable to draw the diagram depending on the information given. So the triangle should be a right angle triangle like this, and hypotenuse is not given. So make sure that you mention that it is the right angle triangle, and one of the side is 5 centimeters, and another side is 12. So tell me, among these, if the triangle is called ABC, which side? Is this 12 or this one is 12? Because we have 12 and 5. Is this 5 and this 12? No, this should be 5 centimeters and this one is 12 centimeters. So we have to work through the remaining side, which is hypotenuse. And How should we do this? We have to apply Pythagoras theorem. So whatever you solve this, make sure that you say by Pythagoras theorem, AB square is equal to AC square plus BC square. Again, AB square, hypotenuse square, is equal to AC square, one of the side, plus BC square. AC square, AB square is unknown, which is hypotenuse, and AC square is 12 square. BC square is what? 5 square. Again, AB square is equal to 12 square. 12 square means 12 multiplied by 12, which is 12 times 12. 140, 144. 144 plus 5 square. 5 square means 5 times 5. It's not 5 times 2. 5 times 5, which is 25. And then we still have AB square, which is the hypotenuse. Now we have to add 144 plus 25. 144 plus 25 is what? 169. So 169. So AB square is equal to 169. But this is just a square of the distance. How are we going to find the length AB? So then AB is the same as taking the square root of 169, which is 13 centimeter. So the length of hypotenuse here is 13 centimeter. And the formula, the Pythagoras theorem, can help. That is the one. Also, we have another question. Example number 2. Let's how to use Pythagoras theorem. This is example number 2. Example says, we have a figure and we are given some size and we need to find the unknown size. In figure below, in figure below, AC is 17 centimeter. AC is 17 centimeter. And the BC is 8 centimeter. We have the length AC and the length BC. And CD is 12 centimeter. And CD is 12 centimeter. Our question is, find the length AD. Find the length AD. But the figure is given. So the figure here is, we have the point A, and also we have the point D, and here the point B, and we have the line joining AD. We have also another point C, which have the line joining AC. It means, according to the information given, the length AC from A to C is 17 centimeter. And the length BC, this length is 8 centimeter. And the length CD is 12 centimeter. So the question is to find the length AD. The length from A to D, which is called the length AD. It is impossible to find the length AD directly before passing through other method of calculating the unknown sides. And therefore here we have to work through the length AB before going through the length AD. So solution for the question by applying Pythagoras theorem. So applying Pythagoras theorem. And for the first triangle ABC, it means the triangles ABC, the length or hypotenuse, the hypotenuse here is AC. So AC square is equal to the sum of the squares of the other two sides, which is AB square plus BC square. So AC square is the same as 17 square, and AB square, AB is unknown, we still AB, and AB square, and the BC is 17 square. So if we want to find the value of AB square, we have to transfer out, subtract. This is 12. This is 8. So BC is 8, not 17, is 8 square. So subtract throughout 8 square, and the final AB square is equal to 17 square minus 8 square, and 17 square is the same as 17 times 17, which is 289. So yes, 289, and 8 square is 8 times 8, which is 64. So we subtract 64. And now we have AB square is equal to 289 minus 64, which gives 225. 225. This is the first part, the length AB. But our task is to find the length AD. Now, let's go to work through the second part of the questions to find the length AD. Again, we apply Pythagoras theorem, which is AD square is equal to AB square plus BC square. Again, AD square is equal to AB square. AB square is already having here 225 plus BC square. BD square. This is not BC square, it is BD square. And the BD is the sum of 8 plus 12. 8 plus 12 is 20 square. So AD square is equal to 225 plus 20 square. 20 square is 400. So 225 plus 400, which is 65. That is AD square. And the final AD is the square root of 65, which is 25. So therefore, AD is equal to 25 centimeters. So this is how to work through the question involving Pythagoras. So before calling the day, let me leave two questions, which is exercise. Question number 1, calculate the unknown sides. Calculate unknown sides. Number one, we have a right-angled triangles, and this triangle is PQR, and the length here is X. This is 17 centimeter, and we have 8 centimeter. This is question number 1. And the question number 2 is, this is 29, and this one is 25, and this is P. So find the unknown X and the P. So thank you very much, and see you next time. My name is Teacher Ame Haji Vuai. Thank you, and see you next time.
Let's study, be educated. Elimu ni kazi. Be educated